Assalamu alaikum students. We are going to discuss about real numbers and its properties. But to understand real numbers, first we need to understand the basic sets like natural number, whole number, integers and all these. So we will start from the very basic set, which is natural number. So natural number is a set which starts from 1, 2, 3 and so on. These dots mean that it goes up to infinite numbers, right? Now you can see that there is zero number missing. We need zero, but this set does not contain zero, right? So the next set which contains 0 and these numbers is whole number, which starts from 0, 1, 2, 3 and so on, right? If you draw this set on number line, you will get like this: 0, 1, 2 and 3. So it just gives you 0, 1, 2, 3, right? You can see that this set starts from 0 and we have all the number on the right side, but we don't have any number on left side. Or in other words, are there any numbers which are not contained in this set? So you can see that negative are not contained in this set. Or you can, if you check this number line on left side, this set does not say anything about the numbers on left side. It means that this set lacks some numbers which are negative numbers. So we need a set which should contain these numbers and the negative numbers, and that set is the set of integers represented by z, and we can write that set in two form: 0, 1, 2, 3 and -1, -2 and so on. So you can see that this set goes in both directions, left and in positive direction right side, in negative direction in left side, right? If we draw this set on number line, we will have like this: 0, 1, 2, -1, -2 and so on, right? Are there any numbers which are still not contained in this set? So what will be those numbers? So those numbers are decimals or fraction, because if you look at this number line, it can only tell you about 0, 1, 2, and this set does not say anything about the numbers which are between 0 and 1, right? So we need decimal or fraction, but those numbers are not contained in this set. So it means that this set is incomplete. We need another set which should contain these elements and the number between these numbers, which will definitely be fractions or decimals. So what will be that set? And that set is called the set of rational numbers, right? And set of rational number cannot be written in this tabular form. This form of writing a set is called tabular form, right? So rational numbers can only be, this form is called tabular form of writing a set. This kind of representation of set is called descriptive form of writing a set, right? And as I told you that this set of rational number cannot be written in this tabular form. We can only write in descriptive or in set builder form. So there is the third way of writing a set, which is set builder form, and in this set of rational number can be represented in set builder form as P by Q. It means that the set of rational number will have elements like this: P by Q, such that this line is called such that PQ belongs to integers. It means that take two numbers which we call P and Q from integers. From this set, take two numbers, write one number on top in numerator and the next one is in denominator. But there is a condition. Condition is that Q has to be non-zero. And why is that? Because you cannot write 0 in denominator, otherwise it will give you nothing. Like if you write 0 in denominator, the result will be undefined. So suppose we take p is equal to 2 and q is equal to -3, so it means that p by q will be 2 by -3, which is equal to -2 by 3. And for this q, why q has to be non-zero? If you take q is equal to 0, suppose p is equal to 2 or 3 and q is equal to 0, then p by q is equal to 3 divided by 0, which is undefined. It is not a defined number because you cannot divide any number by 0. Okay, so you can see that all integers can be represented, can be written in p by q form. For example, if you have 2 or 3 or 5, 5 belongs to integers and 5 can be written as 5 divided by 1, which is like p by q form. It means that 5 is an element of integers and 5 is also an element of rational number. Okay, so if we draw a number line, and can we say that all the points on this number line, all the points on this number line can be represented by rational number? It's not correct. Why? Because there are some points for which we don't have any rational number. And why I'm saying that? Because we have irrational number. Irrational number would be represented. For irrational number, there would be some points on this number line, but that irrational number are not contained in this set. It means that this set is not complete as well. There are irrational number which are not contained in this number. And what kind of number are those? Irrational are represented by q prime. Like these two sets, rational and irrational, they are disjoint, right? Like they don't have any common numbers between them. So irrational numbers are example of irrational numbers are pi, e, and all imperfect square root, 2 square root, 3 square root, minus 5 square root. But don't write that negative inside the square root because that will become an imaginary number. So all imperfect square and this pi and this one are called irrational number. And why they are irrational number? Because these numbers cannot be written in p by q form, right? And in decimal form, these will be non-terminating and non-recurring. Okay, so you can write like there are infinite examples of irrational numbers. So let's take a few examples of rational and irrational numbers. So rational and irrational, they are represented by q and q prime, right? And examples are, suppose all integers 1, 2, 3, 3 by 4, 22 by 7, right? And 3.14, all these are rational numbers. If I write 36 square root, that is also a rational number because square root of 36 is equal to 6. Okay, and opposite to these are irrational, which are pi, 3 square root, e, and 7 square root, minus 8 square root, right? And like lots of example. What is the next difference between rational and irrational? In decimal form, These will be non-terminating, and non-recurring. For example, if I write 2 square root, that will be 1.412367921, and it keeps going. I remember up to 1.41, and I'm not sure about these numbers, but I wrote this in a way to make you understand that there are no repetition. You know, these numbers are not repeating, but it keeps going, right? So non-terminating, non-recurring. And in this one, for example, 1 by 3 is equal to 0.333, it keeps going, but these are non-terminating, recurring. Non-terminating, recurring, right? Okay, and sometime usually people ask about pi is equal to 22 by 7, but I wrote pi in irrational and 22 by 7 in a rational group of rational number set. So why did I do this? Because this is p by q. 22 by 7 is p by q form, so it means that if we convert this number into decimal form, there will be a group of number which will be repeated. For example, 22 by 7 is equal to 3.14236, something like that. I'm not sure, but there are, I think, 7 number. Group of 7 number are repeating, right? It will keep going. So still there are some repetition, but in case of pi, which came from circumference of circle divided by its diameter, so there is no repetition even after billions of numbers. So that's why pi and these numbers are irrational, because they are not non-terminating, non-recurring, and these are recurring. And the point you need to understand that why pi is irrational and 22 by 7 is rational, because of the reason that this is in p by q form, and in decimal form there are a group of 7 number which are repeating after one another, right? So because of this repetition and this p by q form, this is rational number. Okay, now come to properties of real numbers. But if you combine this rational and irrational, you will get the set of real number. Rational union irrational is equal to the set of real numbers. Okay, let's draw the concept map of this rational of this real numbers in all these set, right? Okay, let's draw the concept map. The first set is the set of natural number. Set of natural number starts from 1, 2, 3 and so on. This is the basic set. The second set, which contains natural number, is whole number, which has only 0 more than this natural number. Okay, so what elements do we need to combine with whole number to make it integers? We need only negative numbers, -1, -2, -3 and so on, and that is called set of integers. And what other numbers do we need to combine with integers to make it rational number? We need fractions or decimals, right? Like 2 by 3 minus 6 by 7, etc. So all these decimal like 0.45. So that's decimals and integers combined in one set. They are called set of rational number. Okay, so, and there is no connection between rational and irrational number. So you have to write this irrational number separately, which is represented by q prime, and it has pi e 2 square root 3 square root minus 5 square root. But make sure don't write that minus inside the square root, otherwise it will give you an imaginary number. Okay, now combine these two sets in one set. So that set will become the set of real numbers. So that big set which contains rational and irrational is called the set of real numbers. Okay, now come to properties of real numbers. Okay, there is one more thing. If you come, as I told you, that don't write that negative inside the square root. What if you write that negative inside the square root? That is called imaginary number, because every number inside the square root has to be square of a number, but this negative 6 is not square of any number, so it does not give you a real number if the result of this minus 6 square root is not a real number, right? Or you can say that minus 1 square root, that is the unit of imaginary number which is represented by iota. Iota is an imaginary number which is equal to minus 1 under the square root, right? Because why this is imaginary? Because this minus 1 is not the square of any number. Okay, so if you take square root of that minus 1, the result is imaginary, like there is no real number which is equal to minus 1 under the square root. Okay, so these are imaginary numbers like 6 iota, minus 3 square root, and all these. So this is imaginary numbers. And if you combine this imaginary and this real number, that big set is called the set of complex numbers. So this whole set is called complex numbers, represented by this C are complex numbers. So complex number has two parts: imaginary, set of imaginary number, and the set of real numbers. And make sure that don't combine them, because they have nothing in common between them, right? If you have any question, you can ask me. So in next video we will talk about the properties of real numbers.